In this video, we'll be looking at application to bearings. You have the definition stated at the top, and in the next slide, you're going to see the cardinal points, which are references from the previous video, which is the introduction to bearings. There's example 1 and 2. Pause the video and copy the questions. So we're looking at bearings problem solving. So the first question is calculate the distance traveled south and the distance traveled east by a ship sailing on a bearing of 150 degrees for 90 kilometers. So first thing you have to do is sketch a diagram. So we draw up our usual grid. This is north. So this ship is sailing at 150 degrees for 90 kilometers. So 150 degrees would be, here is 90, this is 180, so 150 is going to fall somewhere between here. So let's draw this. So this is our bearing here, and that is 150 degrees. This is 90 km. The question is asking us to find the distance traveled south and the distance traveled east. So this is south, so the distance traveled south would be the distance coming down, and then the distance traveled east would be the distance going this way towards our point at the end there. Now remember, this is south and this is going east, so it's coming this way and then it's going that way. If you notice, south and east forms a 90-degree angle, right? So we now have a right angle triangle. We could solve this, that is the distance of this side and the distance of this side, by using our trig ratios, which is sine, cos, and tan. So coming down is south, so let's just name them according to axes. So this becomes y and this becomes x, right? So before we decide to solve inside here, we need to find an angle, either at the bottom here or at the top. So since we know that from here to this bearing line is 150, and then from north to south is 180, we could simply find what is this angle. This angle is equals to 180 degrees minus 150 degrees. From here to here is 150, and from north to south is 180. So when we subtract it, we're going to get 30 degrees. So the angle up here is 30 degrees. So since we know this angle, we could find for our sides. So if I'm standing at 30, this becomes my opposite side, and this is the hypotenuse. So we're finding for x first. So with x, we have our opposite side and the hypotenuse. So opposite, and as x, the hypotenuse is 90 km. So let me write 4x up here. Now, which one of our ratio carry opposite and hypotenuse? Let me just put a refresher. SOH, CAH, TOA. So opposite and hypotenuse is in sine. So for this, we're going to use sine. So sine theta is equals to opposite over hypotenuse. Sine 30 is equals to the opposite side, which is x, over the hypotenuse, which is 90 km. Put this over 1 and then we cross multiply. X times 1 is going to give me x, and 90 times sine 30 is going to give me 90 sine 30. Using our calculator, x is equals to 90 sine 30, and that's going to give me 45 km. So this is the distance traveled east. Now let's find for y. So for y, that would be this way. Now If I'm, again, we're using the same angle, so now this becomes my adjacent side, and this is still my hypotenuse. So now we're working with adjacent, which is equals to y, and the hypotenuse, which is equals to 90 km. So adjacent and hypotenuse is cosine. So we say cos theta is equals to adjacent over hypotenuse. Cos 30 is equals to the adjacent side, which is y, over 90. We put this over 1 and we cross multiply. So y times 1 is going to give me y, and 90 times cos 30 is going to give me 90 cos 30. Y is equals to, we put this into our calculator, 90 cos 30, and that's going to give me 77.9 km. So we can say hence the distance traveled south is 77.9 km and east is 45 km. And this is how you work an application to bearings using sine, cos, or tan. Example number 2. Determine the distance traveled north and the distance traveled west by a yacht sailing on a bearing of 310 degrees for 75 km. So the first thing we do is we draw our grid. This is north. So this yacht is sailing on a bearing of 310 degrees. So that means here is 270, here is 360. So 310 would fall somewhere in between. So let me do that there. And it's traveling for 75 km on a bearing of 310 degrees. They want you to find the distance traveled north and the distance traveled west. So the distance traveled north, let me just erase this from here, would be the distance going up, and then the distance traveled west would be the distance coming across, right? So let me just extend this a little. Good. Now this is going north and this is going west. If we're going to use our axes, this becomes y and this becomes x, right? So we need to know an angle. So we need to know this angle inside here. If from north come all the way to the bearing line is 310 and the entire rotation is 360, then we could find what is this angle. This angle becomes 360 degrees subtract 310 degrees, and that's going to give me 50 degrees. So the middle here, the angle here is going to be 50 degrees. Now let's start solving for our side. So the first one we're going to work is for x. So if I'm standing here and I'm trying to find for x, remember our 90-degree angle is here. This becomes my opposite side, and this is the hypotenuse, right? Good. So opposite and hypotenuse. Opposite is x and the hypotenuse is 75 km, and this is sine. So we say sine theta is equals to opposite over hypotenuse. Sine theta is the angle, which is 50, is equal to the opposite side, which is x, over 75. Put this over 1 and then we cross multiply. X times 1 is going to give me x, and 75 times sine 50 is going to give me 75 sine 50. Using our calculator, put that in. 75 sine 50 is going to give me 57.5 kilometers. Now let's find for y. Now if I'm standing here, this becomes my adjacent side, and this is the hypotenuse. So we're working with adjacent and hypotenuse. The adjacent side is y, the hypotenuse is 75 km. So adjacent and hypotenuse would be cos. So cos theta is equal to the adjacent side, which is y, over 75. We put this over 1 and then we cross multiply. Y times 1 is going to give me y. 75 times cos theta is going to give me 75 cos theta. Y is equal, so we put that into our calculator. 75 cos, sorry, theta is 50. So this should be 50. Here should be 50. So 75 cos 50 is going to give me 48.2 km. So we could say now, hence, the distance traveled north is 48.2 km and west is 57.5 km. And again, this is how you use sine, cos, and tan to find to work application questions with bearings. This is example number 3. Pause the video and copy the question. Example number 3. By drawing a diagram, determine the bearing on which a ship sails from port if it finishes 40 km east and 20 km south. So we have to sketch a diagram first, so we draw up our grid. So in this case, it's different from the first two where you have to find the distance traveled. This one, they gave you the distance. So it went 40 km east, which is north, south, west, east. So it went 40 km east and then 20 km south. It's 20 km south. So it went 40 east and 20 km south. They want to know, determine the bearing on which the ship sailed. So let me just put this down. So the bearing they want to know is this entire angle here, right? Now we know from here to the east line is 90 degrees. So we have to find what is this angle inside here. And since we have a right angle triangle and we know two sides, we can go ahead and find the missing angle. Now, if we have to find this angle here, then, and I'm standing here, this becomes my opposite side, and this becomes my adjacent side. So we're working with, let me write them back up here, SOH, CAH, TOA. So adjacent and opposite, it's tan. So we say tan theta is equals to opposite over adjacent. Remember, we're finding an angle now. So tan theta is equals to the opposite side, which is 20 km, divided by the adjacent side, which is 40 km. Tan theta is equals to 20 divided by 40 is going to give me 0.5. I want theta, so theta is equal, so when I take tan across, it becomes tan inverse 0.5. Theta is equal, so let's use our calculator. The second function, tan 0.5, and that's going to give me 26.6 degrees. Now this is not the answer. 26.6 degrees is the angle inside here. right? So let me just put in 26.6 here. They want to know the bearing. So the bearing would be from all the way up north, come straight to this bearing line. So to find the bearing, we would have to add this 90 degrees that we know with this 26.6 degrees. So the bearing is going to be equals to 90 degrees plus 26.6 degrees. And when we add the two, we're going to get 116.6 degrees. So the bearing that this ship travel on is 116 degrees when it travel 40 km east and 20 km south.